Karl Popper, a renowned philosopher of science, is known for his profound insights into the nature of scientific inquiry and the philosophy of science. His work has significantly influenced the scientific community, particularly through his advocacy for critical rationalism and his formulation of the concept of falsifiability as a criterion for scientific theories. One of his most famous quotes encapsulates his philosophy succinctly. "Science must begin with myths, and with the criticism of myths." This quote by Karl Popper captures the essence of his philosophy, emphasizing the dynamic and iterative nature of scientific progress. Let's explore its meaning and implications in greater depth. Science and myths. Popper begins by stating that science must begin with myths. This might seem counterintuitive at first glance, because myths are often considered the antithesis of scientific reasoning. However, Popper uses the term myths to refer to the preliminary ideas and imaginative conjectures that spark scientific inquiry. These are the initial hypotheses or bold ideas that, while not yet grounded in empirical evidence, provide the starting point for further investigation. Historically, many scientific breakthroughs have their roots in what were once considered myths or speculative ideas. For instance, the ancient Greek philosopher Democritus proposed the idea of the atom, a concept that was purely speculative and lacked empirical evidence at the time. Yet this myth laid the groundwork for modern atomic theory. Similarly, the heliocentric model proposed by Copernicus began as a radical departure from the geocentric view, challenging long-held beliefs and myths about the universe. The role of criticism. The second part of Popper's quote, "and with the criticism of myths," highlights the crucial role of critical scrutiny in science. For Popper, the growth of knowledge depends on our ability to critically evaluate and test our hypotheses. This process of criticism involves subjecting our ideas to rigorous empirical tests and attempting to falsify them. In other words, science advances not by proving hypotheses correct, but by systematically eliminating those that are incorrect. Popper's principle of falsifiability is central to this process. A theory is scientific only if it can, in principle, be falsified by evidence. This means that for a theory to be considered scientific, there must be possible observations or experiments that could show the theory to be false. For example, Einstein's theory of general relativity made specific predictions about the bending of light around massive objects. This prediction was tested during a solar eclipse in 1919, and the results confirmed the theory. However, the theory was considered scientific because it was possible to conceive of observations that could have disproven it. The evolution of scientific knowledge. Popper's philosophy underscores that scientific knowledge is not static, but evolves over time. As we criticize and test our theories, we discard those that fail to withstand scrutiny and refine those that survive. This iterative process leads to a closer approximation of the truth, even if we can never claim to have reached an ultimate or final truth. This view contrasts with the idea of science as a steady accumulation of facts. Instead, Popper sees scientific progress as a series of conjectures and refutations. Each new theory stands on the shoulders of its predecessors, incorporating their strengths and correcting their weaknesses. This dynamic process ensures that science remains a self-correcting and progressive endeavor. Implications for scientific practice. Popper's insights have profound implications for how we conduct scientific research and how we interpret scientific findings. His emphasis on falsifiability and critical testing encourages scientists to design experiments that can potentially disprove their hypotheses, rather than merely seeking confirmation. This approach fosters a culture of intellectual humility and openness to new ideas, as scientists must always be willing to abandon their theories in the face of contradictory evidence. Moreover, Popper's philosophy reminds us that scientific theories are always provisional. No matter how well a theory has been tested, it remains subject to revision or replacement in light of new evidence. This perspective guards against dogmatism and promotes a healthy skepticism that is essential for the advancement of knowledge.